Good. Okay. So next topic is data types. So we have seen variable types. Now in the variable syntax, you observe data type is there. That is the one I meant. Yeah. So data type specifies the size and type of values that can be stored in the memory. So what type of data? What is the size? How much size it occupies in the memory? So that can be specified with this data type concept. There are two types of data types. One is primitive data type, non-primitive data type. So primitive data type, you can store only single value. Any primitive data type, you can store only single data. One data only can store. If you want to store one more data, you have to declare another variable. But the non-primitive data, you can store multiple values at a time. It's like string. See the group of characters, right? String means a collection of characters. So string S equal to Java, JAVA, a collection of characters. So multiple values you're combining and storing. Then array also you can store at a time more values. Enum also more constants you can store with the enum concept. Interface also contains constants, methods, and abstract methods. That's interface. Class inside you have seen many members, right? You have variable, one member, methods, blocks, and constructors. These are all another members. Class also one data type, but it comes under non-primitive data type. So class also a type, one data type. So what are the primitive data types? There are 8 primitive data types. We have boolean, char, byte, short, int, long, float, double. So these are the 8 primitive data types. So let's go in deep one by one. The first one is a boolean data type. So why you will use a boolean data type? When you can use, if your value on the right side is true or false, then you can use a boolean data type. So when you can use a boolean data type on the left side, when the right side value is true or false, then the data type must be on the left side boolean. Remember that. So boolean b equal to true. See, right side is the true value, and true will store in the b. B data type is a boolean. So boolean b1 equal to false. False is another boolean value. False will go and copy in the b1, and this b1 data type is a boolean data type. So boolean bn. So I didn't assign any value. This is just a variable declaration, like global variables you can declare like this. Or local variable you can declare, but later, before using this bn, you should use that value. You have to assign the value for bn before using this bn variable. Default value for a boolean is false. If you don't declare, the default value for a bn is false. False will store there. JVM will give this default value for this bn. Int x equal to 20. Int y equal to 10. See, 20, 10, these are all integer numbers. That's why I'm using integer data type. Based on the data type value, the value you're using on the right side, so that will be data type. That data type you have to write on the left side. So then variable name, assignment operator, the value. You store the value in the x. Now x contains 20. So then y contains 10. So this is called assignment operator. These are all called assignment operator. And this is called double equal to is called comparison operator. So there are other operators also. I'm going to introduce more operators here. The conditional operators, greater than, less than, greater than or equal to, less than or equal to, equal to, these are all conditional operators. So when you use conditional operators between numbers, what is the result you will get? A Boolean value you will get. Either true or false you will get. Again, remember this point is very important. If we use conditional operators between numbers, the result will be a Boolean value, either true or false you will get. Either true or false you will get. So Boolean B2 equal to C, X greater than Y. What is the X value? 20.
20.
Greater than, what is the Y value? 10. So 20 greater than 10. So what is the output you will get?
True.
True or false?
True. True.
True. That's a true. So true you will get. Okay, you will get a true. So this is how you can evaluate the expression. This is the expression we call this. This is called expression. So expression, this is a value. You're getting a value. Internally, computer will calculate this value. 20 greater than 10, true. So true is what type of data type? Boolean. That's why left side data type is a Boolean. And the true will store. This output will store in the B2. So the same way, X less than Y. What is the X value? 20. 20 less than 10. What I'm saying, 20 is smaller than 10, I'm saying. Statement
False.
is true or false? False.
False.
So false will store in the B3. So this expression output, see, I declared here the variable I'm using here. I'm using here and here. N number of times you can use one time declaration and use the value variable name in all the places wherever you want to do your operations. And the data only we can do operations like plus operator, minus operator, like multiplication, division, comparisons, conditions. You can write all this on the data. The data will store in the variable, right? The data will store in the variable. That variable name you are calling. If you call that variable, the value what is there in that variable, you will get it here. Then evaluates like this. Internally it evaluates and give the output. So X double equal to Y. 20 equal to 10, I'm saying. 20 is equal to 10, I'm saying. Is the statement true or false?
False. False.
So false will store. The B4. False is of type Boolean. That's why data type is a Boolean. So int I equal to X plus Y. What is the X plus Y's output?
30.
30. That is what data type? Integer. That's why the left side is the data type for the I is integer. So this is the how you can use all the Boolean data types. So logical operators also there. There is and, double ampersand we call this. This is called so and operator. And this is the R operator. R operator, you can see two pipe symbols. Two pipe symbols are there. There's a R. R means what? Any one. Any one. That's R. And means both. Both. Not equal. So you're saying not equal. That's a negation purpose. You use this exclamatory mark. So if you see, first let me explain AND operator. If you use between two variables, what is the output you will get? See, variable 1 is true. The operator is AND operator. And the variable 2 is true. True and true. So what is the result? You will get a true. That means both are a true. The output also will get a true. Next, variable 1 value is true and variable 2 value is false. True and false. False you will get. False and true. False you will get. False and false. False you will get. Can you observe here? Both true, then only true output. But any one is false. In the AND case, what is the result you are getting? False you are getting. So you need to remember this table. It's going to be very easy to evaluate any expressions. Same way, not equal. See, true not equal to false. That's the right? That means result is true. True not equal to true. So false. True equal to true, right? But I'm saying true not equal to true. So a false you will get. False not equal to true. True you will get. False not equal to false. False you will get. So this is the results. So between two variable data, if you use this operator, what is the output you will get? That's I have given here. Same logical operator. So logical operator is true or true. The output is true. Any one is true, the output you will get a true only. True or false, true you will get. False or true, true you will get. False or false, false you will get. See here you can observe. Only one case it is becoming false. All other cases it is true only. That's the difference between and or operators. And means both are true, true you will get. Both are not true, always you will get a false there. But our case, any one is true, the output you will get a true one. Only false and false case only you will get a false. So this is the logical OR operator. Any questions? So this is the tables, very, very important. So you need to remember these tables. Okay. So next, let's understand this. Here I have used this B and B1. What is the B value? You can see that B value is true. B1 is false. Now B and B1, if you do, what is the output you will get? B and B1.
True.
True.
So B is a true.
False.
I'm using AND operator.
False.
B1 is false. AND case, what I told you, both are true only, then true you will get. If both are not true, you will get a false.
False.
Here one is true, one is false. Then what is the output you will get here?
False.
False. So false will store in the B file. Now B or B1. B R case, what I told you, any one is true, the result you will get true. Now here B is true or B1 is false. That means what is the output you will get?
True. True.
True.
True. So you will get a true here. B not equal to B1. True not equal to false. So what is the output you will get?
Equal to, not equal to.
True not equal to false.
True.
True. That's right. True is not equal to false. That's true. So true you will get. True will store here. So this is how you can know evaluate expressions on the right side one. Based on the right side value, your left side should be declared. Okay. Next, second data type is char data type. Second primitive data type is a char. What is char? It is used to store a single character in memory location. What is single character? It can be numbers, it can be alphabets, it can be special characters, it can be spaces, it can be anything that will be treated as a character. But only single character you have to store using char data type. So the value should be enclosed within single quotes. See, the value is enclosed in single quotes. Okay, so char C equal to D. C within single quotes, only one character. Char C1 equal to small a in single quotes. Char C2 equal to dollar in single quotes. Char C3 equal to single quote space. Okay, so char C5 equal to 5. Char C4 equal to A3. Is this the one character or two characters here?
2 characters.
Okay, that's why this is not a valid no declaration of char data. So you should not use two characters. This is not a valid declaration. So this will throw error for you because it's not one. That's why it will throw error. Okay. So, but the default value for the character is Unicode. So this is the Unicode. You can use this Unicode. So char occupies 16-bit of memory. That means 2 bytes. It occupies 1 byte equal to 8 bits. So 2 bytes means 2 multiplied by 8 means 16 bytes. 16 bit. 16 bit of memory or 2 bytes. Both are same. So one time if you declare char c equal to d, 2 bytes of memory occupies in the memory area. Here 2 bytes, here also another 2 bytes, here also another 2 bytes, another 2 bytes, another 2 bytes. But this is not a valid so declaration of character because it's not single character, right? More than one character, it's not treated as a character. So very clearly telling one character only can store in the char data type. Next, integers. To store integer type of data, you can use byte, short, int, and long. So byte occupies 8-bit of memory. Short occupies 16-bit of memory. Int occupies 32-bit of memory. Long occupies 64-bit of memory. So byte before equal to 5. So this is so occupies 8-bit of memory. That means 1 byte. Short s equal to 1. So this will occupy 2 bytes, same as a char. So int I equal to 10, 32-bit of memory occupies. Long L equal to the bigger integer numbers. For example, your phone number you want to declare, you have to use long only because that's a bigger integer number. So this long occupies 64-bit of memory because bigger memory this one. Integer is 32-bit one. So long is 64-bit memory. So such kind of integers, if you want to declare and assign the values, this is a compact code. Int a equal to 5. What is you are doing here? 5 you are assigning to a and you are creating integer type of data. Int b equal to 6. And the equivalent to this one is you can declare first variable. The next line you can assign the value. This is also same as this one. The single line you are finishing here, declaring a variable and assigning a value. But here first you are declaring a variable and next line you are assigning a value. Both are same. So int b equal to 6. Int b and b equal to 6. These are 2 lines and you are finishing here in a single line. So the compact code and this is the longer code. That's it. So int c equal to 7. Int d equal to c plus 1. C value 7. 7 plus 1, 8. 8 will store in the d. Here, first you are declaring the c variable, then assigning the 7 to c. D you are declaring and d value you are assigning to d c plus 1 value. C plus 1 means what is the c value? 7. 7 plus 1, 8. So now 8 will store in the d. So this is the how your variables you can declare either this is also correct. This is also correct. Both are perfect. So next decimal values. Any integers, please remember you have 4 data types: byte to, short to, int to, long. So any integer numbers, either negative integers or positive integers, you want to store, what data type you need to use? Byte, short, int, long. You can use. So decimal values, if you want to store, like a point, no, after number there is a decimal point, right? That kind of data, if you want to store, you can use float or double in Java. So float occupies 32 bit of memory, same as integer. Same memory, integer memory size also same as a float. Double occupies 64 bit of memory. See, float f equal to 3.6 capital F. Capital F tells that it is a floating value. Double D equal to bigger memory, it occupies 64 bit of memory. So bigger decimals, if you want to specify, you need to take a double, not float. Okay, like a long, how we are taken, here you have to take the double data. So why we will get a type mismatch error? So when the left side and right hand side data is not matching, then you will get a type mismatch error. Then how can you solve that issue? The first reason is left hand side and right hand side data type is not here. It's not matching. Then you can use it. You will get a type mismatch error. Second reason for a type mismatch error is left hand side variable memory size is smaller than right hand side variable memory size. Same data type, but memory sizes are not same. Such cases also will get a type mismatch error. Both left hand side data and right hand side data is same, but memory sizes are not same. Such cases also you will get a type mismatch error. Then how can you solve this type mismatch error? By doing a typecasting. We can do a typecasting. We can solve that a type mismatch error. What is this typecasting? So it is a process of converting the value of one data type, interface, class into another data type, class, or interface is called typecasting. So what is typecasting? It is a process of converting the value of one data type, class, or interface to another data type, or class or interface format is called typecasting. So typecasting syntax is this one: data type. So variable name equal to bigger memory variable name or value on the right side, and put the parenthesis on the right side variable before and write the left side data type. This data type you write here. This data type you write here. Interface 1 variable 1 equal to interface 2 variable. This is a different interface variable, and this one is a interface 1 variable. Both are not matching. You will get a type mismatch error in this line. Then you are to avoid that type mismatch error, apply the typecasting. So typecasting means you convert the right side variable into left side format. Then your issue will be solved. So here is the examples you can see. Int I equal to 50. Start S1 equal to I. So I am assigning to S1. Start to integer, same data type or a different data type? Both are same data type, right? Integer family. Both are integer family. But what is the memory size of short to? What is the memory size of short to? And what is the memory size of integer?
Int 32.
Int 32 and short to 16. That means, can you fit this? Can you copy 32 bit in the 16 bit? Can you copy 32 bit memory in the 16 bit?
Use typecasting, we can use.
We cannot copy, right? We cannot copy 32 bit in 16 bit because 16 bit is smaller, 32 bit is bigger one. You cannot copy. So that's why you will get a type mismatch error. First understand why you are getting a type mismatch error here. First understand both are integer family, but what is the reason you are getting type mismatch error here? The memory sizes are not same. Memory size is bigger. You are copying bigger memory into smaller memory. How it will fit? It won't fit, right, in the small memory. Still 32-bit, 32-bit inside your, you're putting in the 16-bit. 62-bit inside 32-bit won't fit. Still 16-bit will be outside only. That is the reason you will get a type mismatch. Then what you need to do, you convert the right side variable into left side format. What is the left side format? You convert the short format. This is called typecasting. So see, now directly you cannot copy this integer value into short, because this is the type mismatch error you will get. The memory mismatch is happening here. That's why you convert the right side value to short format, and then you can copy into S1. This I value you can copy to S1. Now S1 is what is the value in S1 now? What is the value in S1?
15.
The I value will be copied. What is this operator is doing? This assignment operator. What is the I value is there that will go and copy into
S1.
S1. So I value 50. So S1 value also 50. Now float F equal to 3.5 F. Int I3 equal to F. Now you will get a type mismatch error. Why you are getting type mismatch error here?
Because of that point to 3.5.
Different
It's
data.
two characters. It is
Data
assigned.
types are different. Memory size are same, but data types are different.
Yeah.
I3 is integer, F is a float. Data types are not matching. That is the reason you will get a type mismatch error. You convert the float into integer. What is the integer number in the 3.5?
3.
3 is the integer number. What is the decimal value here? 0.5. 0.5 is the decimal. Integer number is 3. So 3 you will get. Now I3 will store 3. So this is how you can, if the data types are not matching also, you will get a type mismatch error. How you can solve that? By doing a typecasting. When you don't need typecasting, see, short S3 equal to 5. Now you are assigning int IT equal to S3. Why you don't need a typecasting? Both are same data type, but memory sizes are even though different, but right side memory size is small. Left side memory size is 32-bit. 32-bit inside easily can fit 16-bit or not. That's why you don't need a typecasting here. You won't get type mismatch error. Char C equal to A. So basically, every character has one integer number. Every character, either it is a special characters or numbers or integers or this alphabets. Every character has inbuilt integer number. That integer number is called ASCII code. So capital A ASCII code is 65 integer number. When you assign the character integer, that internal number of this A will go and store in the integer. Now character is 16-bit, integer is 32-bit. So happily it will go and copy the C value. What is the C value? Capital A. Capital A integer number is 65. 65 will store here. So that is what happening in the character case. Every character is having one integer number internally. That is called ASCII code. So how many of you know ASCII tables? You can see, you can Google it, ASCII table. Every character, you can see here, every character has ASCII codes. That is called binary number, we can call this. Binary numbers also we can call this. Yeah, can you see here? Capital A ASCII code is 65. Capital B is 66. Small a ASCII code is 97. Small b is 98. Like this, you can have all the three ASCII codes. This space ASCII code is 32. exclamatory mark 33. So dollar you have 36. So 0 you have 48. 1 you have 49. Like that, every character has a ASCII code. These are all, every character, see this character has a ASCII codes. See @ symbol is 64. A is 65 and Z is 90. Small a is 97. Small z is 122. Even a brackets also. These brackets also have ASCII codes. So every character in the keyboard you are seeing which has a ASCII code. Okay. So that ASCII codes will store when you assign the character to integer. So now C will be C integer number will go and copy in the I. Now I value, what is the I value? Capital A ASCII code. What is the capital A ASCII code? 65. 65 will store in the I. Not capital A will store here. So here 65 will store. Capital A integer number will store here. When you assign a character to integer, the character integer number will go and store there. So this is all about data types. Tomorrow I'll cover a string and we can